stack. It's an ADT. So it's not a data structure. ADT is abstract data type. So stack is an ADT in which items are only inserted on or removed from the top of a stack. A pictorial representation of it includes a stack of cafeteria trays, a stack of coins, a stack of boxes, a stack of shirts. The property associated with a stack is last in, first out. The very last one in is the first one out. So if you to push something in, this is push. You put another shirt on top of the original stack. But when you want to remove something from a data structure, from the ADT, you will pop it. The top one, which is the last one in, is the first one to go out. Okay, so this is what a stack is. Let's move on to some of the high-level descriptions of operations. So in a general stack implementation, you have three different types. One is the constructor. Constructor is the point of entry in creating or instantiating a stack. It doesn't have to be an empty stack. It could be a stack with already stuff in it. This is the constructor part of the operations. The second part is what we call transformers. A transformer is just a whole bunch of verbs. These are actions or behaviors that effectuate changes inside the stack. There are two operations that are common to stacks. One is push and the other one is pop, which I just talked about. And the third one is observer or observations methods. These are methods that peeks into the state of your stack. You could also have an observer called isEmpty. So there's several types of observers out there. These are typically just read-only operations. And transformers, these are mutations that effectuate changes to the stack. So anyway, these are just CS terms that we use frequently to observe these things. So let's move on to the next one. The effect of a stack is. So you start up with, let's just look at the top one. There's nothing here. The very first element gets in when you push the block 2 into it. So top becomes block 2. So top always points to the top of the stack. This is an observer. Push and pop, these are transformers. So we keep pushing stuff into it. The new element that gets pushed sits on top. So the top also gets updated every single time. When you pop something, you pop the top. So the top is gone. This also means that your top has to be updated as well. So when you push 4 back in, the top is updated to 4 because 4 is now. So this is last in, first out. So that's the effect of a stack operation. I think it's very simple to illustrate. This is some implementation details with respect to the data structure of a stack. We could be using an array for it. We can also be using a linked list. So there's an array-based stack and linked list or list-based stacks. We'll detail the differences between the two, and then we get into the order of growth analysis, big O notation, to see which one is more efficient than the other and why we're using either or not both.